Thank you, Alison, for your kind words. My wife, Wendy, is away tonight. In fact, she made use of seat sale prices to fly out home to visit her father in Alberta and gives her regrets. And so I hope my two sons are not too rambunctious with each other at home. Anytime a geologist gets invited to speak at an event sponsored by theologists, I know that's not the right term, but it rhymes, there inevitably arises the question of how do I deal with the problem of origins? Some people might ask how I, as a Christian, can work in such a science which contradicts or maybe even has disproved the Bible. Others might ask how I, as a geologist, can condone those archaic teachings of a church that proclaims a ridiculously young age of 6,000 years for the age of the earth. Most people, perhaps sensitive to the person, are not quite sure how I stand, will simply ask me, how do I rationalize my geological education with my Christian experience? Well, I won't disappoint you. I'll get to that, but I've got lots of time to do it tonight. And I want to do it by examining the concept, or our concept, of time. Do you remember the story of Paul when he was being delivered to Rome? He set sail and he sailed to Crete, but it was getting late in the season. The book of Acts tells the story. We spent a long time in Salome until it became dangerous to continue the voyage. Paul gave this advice: "Men, I see that our voyage from here on will be dangerous. There will be great damage to the cargo and to the ship." But the army officer was convinced by what the captain and the owner of the ship said, and not by what Paul said. Now, because the harbour at Salome was not suitable for wintering, most of the men were in favour of putting out to sea, if somehow they could reach Phoenix, a safer harbour, to spend the winter there. You probably know the rest of the story. En route to Phoenix, the wind blew up and they were bounced around by storms in the Mediterranean, brushing the coast of Libya and ending up being shipwrecked on Malta. And there they spent the winter. I'm not too worried about the details of the story. What I want you to think about, to stop and think about, is the mindset of these men who were looking for somewhere to spend a winter. Now, I'm sure their winters didn't drag on as long as ours do into the month of May, but there they were, marooned in an island for 3 months. And they had planned it that way. They thought they might stop in Crete for 3 months. They ended up in Malta, but nevertheless, they had planned to stop somewhere for 3 months. One wonders what they did. Of course, in Malta, Paul soon got very busy performing miracles and preaching the gospel, but what about the other men, the sailors and the soldiers and the captain of the army and the ship captain and so on? There they were, cooped up in a little island for the winter, biding their time until weather conditions improved. 3 months. Wouldn't you like 3 months right now? I know my students would. It might bring to mind the journeys of the explorers of the 16th and the 17th centuries. They headed out to sea for long, indeterminate periods of time. Columbus set out on his journey with a vague idea of how big the world might be. The fact that he was 25% out meant that it was fortuitous he found America, otherwise he would never have reached Cathay with the meager supplies that he had. Magellan, in his voyage around the world, planned to be gone for several years. The ship took 3 years. Of course, Magellan never actually made it. Or Marco Polo on his voyage to the Forbidden City. For months on end, he journeyed across the mountains, deserts, forests, and steppes of Central Asia. Can you imagine living in a day when it was a whole day's journey just to get to Halifax? Somehow these ancient mariners and wanderers seem a bit remote in our understanding. They're so well known, the stories are so well known that they almost seem mythical, and we rarely think of the cost to their family, their business, their personal fortune that was risked. If the journey turned out well, of course, there was the potential for fame and fortune. But there was always the potential that the journey would be the end itself, and there would be no fame and fortune. I wonder how many Columbuses, or would-be Columbuses and Marco Polos there are, or there were, that we know nothing about because they never came back. A little closer to home, and maybe a little closer in time, are the explorers of the Canadian West and the Canadian North. It's maybe a little bit easier to relate to people like David Thompson and Alexander Mackenzie, or Anthony Henday, When he set out from Fort Garry, he had heard legends of the shining mountains far across the prairie. It took him 3 months to get there, to the Rockies, and 9 months to get back, before he could spread the news of what he had seen. Even today, when we travel by car on paved highways, it seems to me that our journeys are shortening. As a child, I recall the major trip that was involved in the 124-mile voyage to visit Aunt Mary in northern Scotland. A few days before we left, the car would be booked into the service station for an oil change, check the brakes, because there was a steep hill on the way, and ensure that everything was in working order. The day before the trip, the gas tank would be topped up and the tyres would be checked. Water would be added to the radiator and to the battery. Oh, and the car would get washed as well. As an avid map reader, I used to spend the evening, or the 2 evenings before, planning all kinds of routes to get there. This was in the days before there were motorways in Scotland and we still drove through towns and cities. My grandmother, I recall, would have endless reasons why we couldn't go this way or that way. One town had a notorious one-way system that no normal person could ever negotiate, and another town was known to have an early closing day that resulted in heavy traffic just when we would be passing through it, so we couldn't go that way either. I used to wonder how the tourists from England ever made it up through Scotland with all these obstacles set in front of them. The journey was spread out over the whole day, with stops for morning coffee and lunch, and if we were lucky, afternoon tea somewhere as well. For the second half of the journey, we agonized over being there too early, because Aunt Mary wouldn't be home from work yet. I still visit Aunt Mary when I go to Scotland, but now I leave my parents' home in the mid-morning, and we get there in time for lunch, driving in the motorways. We visit her, maybe go and see one of her nieces or nephews, and still get back to my parents' home before it's totally dark. In spite of the accelerated trip, though, my sons still ask, "Are we there yet?" And I don't remember if I asked that when I was their age, but I'm sure I must have, because it was a much longer journey. And it's not just in Scotland that the journeys are getting shorter. I've observed a visible increase in the rate of travel since I moved to Nova Scotia. When I first started work in Nova Scotia, I worked in Cape Breton Island, and I always considered the first day was for getting there. I would pack up at this end in the morning, unload at the other end later in the day, and call that a day. Gradually, maybe as I became more efficient about getting packed up and unloading, that would become a half-day's work, and I could sneak into my office in the morning or perhaps explore a stream after arriving. And of late, I've been known to make the trip an evening affair. That way I can still do most of a day's work before leaving. A couple of weeks ago, I had the great joy of being invited to participate in a photographic tour and rock collecting trip to the northernmost tip of Cape Breton Island by helicopter. We left Acadia about 10:30 in the morning. We had lunch in Bedeck and were whipped over the spectacular fall scenery of Ingonish and Cape North to be wandering the mountains behind Meat Cove by 1:30 in the afternoon. After some sightseeing and photography on the west coast of the island, we returned to Shubenacadie just right at sunset. Several times through the trip, I think we all caught ourselves thinking, this is happening just too fast. We wanted to make it spin out. I want to contrast that with an item that was written by Annie Bird in the local paper a couple of years ago. Maybe you read her writings as she reports on the goings-on in Avonport. She always has such a colourful pen and an optimistic outlook on life. Her column is probably my favourite part of the paper. Annie had been to visit friends, I think it was in Port Hawkesbury, but it was Cape Breton somewhere, and she described her trip back, stopping along the way to visit the sites, have tea with friends, or catch up on what her former neighbours were doing, and investigate interesting shops in practically every community along the road. It took her days to get back, and I don't think she ever touched the highway. That's a different pace of life from ours today. At the moment, NASA is planning a manned mission to Mars. It will be an 18-month voyage, reminiscent of the travels of the great explorers of the 16th and the 17th centuries. And just like in the days of sail, there's quite a lineup of people who want to go, maybe for different reasons this time, but there they are, eager to participate. There's a difference, though. At no time in that voyage will those people ever actually be out of communication with the Earth. Those of you who are over 40 might remember the first trips of the astronauts around the moon. I think it was Apollo 8 that was the first spacecraft to go around the moon in Christmas 1967 or Christmas 1968. Do you recall the apprehension the whole Earth experienced as we waited for the astronauts to come out from behind the moon, when we would hear their voices again and they would regain contact with the Earth? Yet they were only out of contact for 3 hours. It's a far cry from Paul in Malta for winter. I think you can see one of my themes tonight. Time has become a very valuable commodity. We live in a world where we must always be able to do anything instantly. Think of the stereotype of the businessman, and what do you think of? It's someone who's traveling with a car phone, a fax at home, a fax in his office. A significant amount of his business is being done on the road. What happens to the mail? He hardly uses it. In fact, I don't think I've really used the mail very much. That's the one with stamps on it anyway. For a business letter anyway that required any action in the last 6 months. I have trouble thinking of more than 1 or 2 examples. I use email or the telephone instead. It makes you wonder what Canada Post is going to do when they're not allowed to deliver junk mail anymore. Last spring, I received a phone call from a former student we had here in Acadia, now teaching in South Korea, asking for a letter of reference to be sent on his behalf to a potential employer. As I couldn't quite make out the address of the employer because of the student's strong Korean accent, I confirmed all the details with him by email. I faxed the letter to the employer, so it would have my signature on it, and received a confirmation from him that he had received my letter. The time elapsed, 55 minutes, much of which was trying to figure out which way down the paper goes in the fax machine. Life moves fast. Equally extreme, but on a local scale, the University Catering Office recently faxed me a brochure for a luncheon booking. There isn't time any longer, it seems, for interdepartmental mail, same-day mail to run. One more example. Have you ever noticed how the news in our newspapers is often out of date when it gets printed? You know the situation. You've heard the story in the news the night before, or you saw it on television. It's not that the events are happening any faster, but the next day you read about it in the newspaper. It's just we're all so much tuned into what's happening now. We have so many immediate sources of information. There's a website on the World Wide Web, for example, where I can view the eruption of Ruapehu volcano in New Zealand, just as it's happening. What they've done is set up 2 video cameras on the flanks of Mount Ruapehu. And these video cameras, every 10 minutes, download an image onto the World Wide Web. I can go into the web and watch where a particular lava bomb may have fallen about 10 minutes beforehand. In fact, given that New Zealand is on the other side of the international date line, from here, I can observe today, Wednesday, a bomb that fell tomorrow, Thursday, in New Zealand. English grammar just doesn't have the tenses to deal with it any longer. I also subscribe to a publisher's service that provides me with a table of contents of several journals up to a month before they're published. When an item of significance appears, I can email the author, especially if I know him, and receive perhaps that day a preprint of that article, all electronically. I only wish I could read and digest the information at the same rate as I can receive it. Is our time really that precious? How has the escalation of its value happened? Have you ever noticed that we no longer do things because we want to do them? We do them if or when we get the time. Or at least that's what we say. Perhaps instead of being completely honest, we say we don't have the time to do something when what we really mean is we don't want to do it. It's become a very useful excuse and well accepted. As a geologist, time is one of the dimensions that I work with every day. And I'm not talking not just about time for daily business, but also time for geological events to happen. Have you ever wondered what is the answer to Bob Dylan's question, how many years can a mountain exist before it is washed to the sea? Or have you tried to estimate how long Robert Burns would have to wait for his lass till all the seas gang dry and the rocks melt with the sun? How fast does it take for a grain of feldspar to grow in an underground magma chamber? How long does it take then to reach the surface and be eroded away to end up as a grain of sand on the beach? What's the life expectancy of a volcano or an island? or a mountain range, or an ocean. Yes, all these things come and go. They're not perennial, they're not perpetual. The geological answer to many of these questions lies in the tens of thousands to hundreds of millions of years range, and I can give you more precise answers afterwards if anyone really wants to know. And although 100 million years may sound like an awfully long time, it's only a small fraction, about 2% of the measured age of the Earth, 4.6 billion years. If you're not a geologist, I'd hazard to suppose that your experience of time is so short that mountains, islands, and oceans seem fixed, stable quantities. In fact, nothing can be further from the truth. Let me digress briefly to describe what this area was like in times gone by. Apologies to any geologists in the audience, you're supposed to know this already. 10,000 years ago, the huge ice sheets had just begun to melt back northwards after the Ice Age. Mastodons roamed in Nova Scotia. They were hunted, perhaps, by the first settlers in the region. Sea level, and we're all worrying about that today, was perhaps 100 metres or more lower than it is today. The mastodons could walk to Prince Edward Island without the fixed link. Indeed, they could walk to Sable Island too if they wanted to. Ottawa was under ice 10 times thicker than the Peace Tower, and the Atlantic Ocean, which I'm going to use as a measure of how time is moving, and is continually widening by plate tectonic processes, that ocean was about half a kilometre narrower 10,000 years ago. Going back to 1 million years ago, Nova Scotia was totally buried by that huge ice sheet that covered almost all of Canada and the northern third of the United States and much of Europe. 1 million years ago, the Atlantic Ocean was about 50 kilometres narrower. 100 million years ago, long before the ice ages, the climate here was subtropical, perhaps not dissimilar from Georgia or Florida today. In fact, the whole world was much warmer, and although the nights still got dark in the wintertime, there were no ice caps at the poles. The Atlantic Ocean was only half as wide as it is now. If we double the age, the Atlantic Ocean will be gone. 200 million years ago, there was no Atlantic Ocean, and the land here was a dry desert. The remains of that are preserved today in the red sandstones of Cape Blomidon. Resident dinosaurs could roam from the hot sandy deserts of the Annapolis Valley to the hot sandy deserts of Africa, or to Argentina, or to Alaska if they chose, because there was no ocean in the way. These were all part of one immense continent. 300 million years ago, keep going back, mountains as high as the Rockies today stretched from Alabama to Norway. Remember, there was no Atlantic now. Nova Scotia lay near the equator, and in lowlands between the mountains, rivers on the scale of the Ganges supported luxuriant vegetation, one day to become the coalfields of our province. Occasionally, a shallow arm of seawater invaded across the lowlands as sea level rose and fell with time, only to evaporate away to dryness and leave us with the rich deposits of gypsum and salt that Nova Scotia has. 400 million years ago, an ancient ocean, a different ocean which preceded the Atlantic Ocean, was closing up as opposing continental masses on either side relentlessly pushed towards each other. At the surface, tropical reefs flourished around volcanic archipelagos, although not much of those survives. But deep underground in huge magma chambers, the granitic batholiths, the granitic highlands of Nova Scotia were forming. The uplands today were crystallizing from hot magma. And jumping back finally to 500 million years ago, before these same mountains were born, the place that was to become western Nova Scotia lay at the bottom of a southern ocean, perhaps somewhere near where Cape Town is today. Thick layers of sand and mud accumulated, which would one day become the slaty bedrock of southern Nova Scotia. Before that there was no here. Although I've only taken you back 500 million years, a mere 1/8 of the age of the oldest parts of the Canadian Shield. Banding around terms in hundreds of millions of years is easy for a geologist because we're used to doing it, but it soon numbs the brain of most other people into thinking that all that happened so long ago as to be virtually irrelevant to us today. But the Earth is still changing by these same processes. We see around us the eroding coastlines of Prince Edward Island and the Minas Basin. Those of you who have property at Medford or Kingsport know only too well that geological processes are happening rather fast as you watch the seafront gradually getting closer and closer to your cottage every year. Woody stumps on the south shore of Nova Scotia are the remains of forests that were inundated by rising sea level this century. And climate also, which is part of the whole Earth system, is constantly changing too, century by century, for better or for worse. In the 1700s, much colder weather than today pervaded northern Europe, particularly in the winter times, and allowed for frost fairs with bonfires lit on the River Thames in London. It doesn't freeze across at all nowadays. In the 11th century, the Vikings explored much of the North Atlantic and made settlement in Greenland and perhaps in North America. That was possible because it was milder then than it is now. 2,000 years ago, as you probably know, Libya was the breadbasket of the Roman Empire. You may not know that herds of wildebeest roamed in what is now the Central Sahara Desert. There are cave paintings inland in Chad and in Mali that show grazing antelopes and wallowing hippos and substantial human settlement in an area that is now hyper-arid. Rainfall never occurs. I wonder if perhaps Abraham's migration from Ur to Haran and to Israel was in part a response to shifting rainfall patterns at that time. Because today, Ur of the Chaldees is a barren, searing desert, still fought over much, but no longer fertile. Well, I hope I've helped you to slow your thoughts down and appreciate that the Earth has experienced time, a lot of it. The Earth's surface is active and is constantly renewing itself, so there's no guarantee that we'll ever find a piece of the very oldest crust of the Earth that's been unmodified by later processes. In fact, a tremendous amount of research time has been put into searching for the oldest rock on the Earth. There's something romantic about finding the oldest rock on of the Earth. I have here a piece of it, at least as far as we know today. You can come and ogle at it later on. It's from near Yellowknife, Northwest Territories, and it recently out-aged the coast of southwest Greenland by some 50 million years. Its age, to set the record, is 3.962 billion years old, virtually 4 billion years old. The Moon, which is an inactive body and doesn't experience plate tectonics like the Earth, is even older. It doesn't renew its surface because it's not going through this cycle of plate tectonics. And samples brought back from the Moon have been dated from the lunar highlands right back to 4.6 billion years. In fact, the very youngest rocks in the Moon are about the same age as this character here, about 3.8 billion years. I have a rock that's even older. This is a meteorite which fell from space and, like most meteorites, can be dated back to the beginning of the solar system, 4.6 billion years. I like to show visiting school groups these rocks. I take them to the oldest rock on the Earth, and then I tell them to look for a rock that's older than the oldest rock on the Earth, and eventually they find a meteorite. One of the significant things about these meteorites is that some of them contain hydrocarbon compounds which are relatively volatile, so we know that nothing much has happened to them since they landed, except that they flew around in space for a few billions of years and landed here within the last little while. Well, there it is. I've told you that the Earth is 4.6 billion years old. How do I know? Well, the simple answer is by chemical analysis of radioactive elements in rocks that decompose, the elements decompose at known rates. For example, isotopes of the element uranium decay to produce lead at a rate that we know. Approximately half the uranium will have decayed to lead in about 4 billion years. In the next 4 billion years, of the uranium remaining, half of it will have decayed to lead. And we can measure the quantities of the parent isotope of uranium and the product isotope of lead, and thereby calculate the age of the sample since it crystallized or formed. The process may sound complicated, but it's really no different from watching the burner on an electric stove cool after you shut it off. 1 minute after you shut the burner off, it cools from 400 degrees to 200 degrees above room temperature. In the next minute, it will cool from 200 to 100 degrees above room temperature. The next minute, from 100 to 50 degrees. It keeps halving the difference until eventually it approaches the temperature of the room. The amount of uranium that remains in a rock is proportional to the amount of time that passed since the rock formed, just the same way as the amount of heat that remains on the burner of the stove is proportional to the time passed since the burner was turned off. Well, that's the simple answer. The more detailed answer is to how we know that the Earth is very, very old is by countless millions of independent observations by Earth scientists, each one itself not necessarily conclusive, but which taken together are mutually supportive and tell a story of eons of geological activity at rates broadly comparable to what we see happening in the Earth around us today. They produce the immense variety of rock types which we find at the surface of the Earth and the landforms which make up our scenery. We may not be able to determine the precise age from many of these observations, but I hope to show you that these observations are compatible at least with an age of a few billions of years. Take, for example, the environments I described for Nova Scotia earlier on. If you'll recall, I described a record of several sheets of ice advancing and melting back, long periods of desert conditions when flash floods transported huge amounts of sand and gravel across the desert floor, millions of years of hot, steamy rainforest conditions, millions of years of shallow tropical seas and salt pans, repeated periods of volcanic activity, eons of mountain building activity, and before that, sediment accumulation in the deep ocean. And that's just here. The record of these events are the substance of this province. And the rocks are identical to rocks being formed elsewhere in the world where those same processes are happening right now, whether it be under the Antarctic ice cap, or in the wadis and sand plains of the Sahara Desert, or in the jungles that form the native vegetation of the Ganges Delta or the mouth of the Amazon, or in the volcanic upheavals of Iceland or Japan, or the quiet waters of the deep Atlantic Ocean where sediment washed down the Amazon River finally settle out, or in the tectonically active mountain belts like the Himalaya where the collision of India with Asia is pushing up the world's youngest mountain belt and the Tibetan Plateau. To summarize then what I've described, the rocks of Nova Scotia, and all the rest of the Earth for that matter, bear obvious similarities in form and in extent to sediments and volcanic rocks being formed in various parts of the world today. They not only have the same appearance, but they're also inferred to have formed by the same processes. These observations are summed up in the principle of uniformitarianism, subtitled "The Present is the Key to the Past." And these observations are fundamental to our understanding of the development of the Earth. Even without the chemical analysis that tell us that the Earth is 4.6 billion years old, it's clear from the rocks themselves that the Earth is very, very old indeed. This assertion that the Earth is almost inconceivably old has proved to be a very divisive argument, which in many places has alienated scientists from Christianity and Christians from science. Unfortunately, it tends to get lost in a whole series of other debates as well, which may have somewhat different objectives. Debates about the descent of man, or the authority of Scripture, the origin of the universe, or the purpose of creation. Let me review this evening the positions of the major opponents in this Age of the Earth debate. First of all, there are the young Earth creationists. These are the people who would determine the age of the Earth by taking a strict interpretation of the genealogies and timelines referred to in the Old Testament. A certain Bishop Ussher in Dublin has been ascribed the dubious credit for coming up with this calculation, although to be honest to poor Bishop Ussher, he didn't do it, he just wrote it down. Many others have attempted this calculation before and after, and the date that is commonly bandied around, the date for day one of creation, was October the 26th, 4004 BC. Now I say that in all seriousness, although I see people smiling. You'll probably hear quite a bit more about this date because Saturday turns out to be the 6,000th birthday of the Earth, according to that calculation. It's interesting to note that Bishop Ussher's calculations are relatively little known by Christians today. They're quite well known in the geological community because of the ridicule that they have received. And I think it's just one of many examples of the alienation of science and Christianity by ignorance. In fact, not just the geologists, even the archaeologists can get in on this one, because cities like Jericho can be dated back, I believe, to about 6000 BC, which is 2,000 years before Bishop Ussher's date. What are we to make of this calculation? Well, the truth about the biblical genealogies is that we cannot definitively date anything from the biblical record alone before the death of Terah, Abraham's father. The Bible just is not that specific. There are gaps. Other attempts that have been made to estimate the date of day one have pushed it back a bit further, to perhaps 6,500 years before the death of Terah, 10,000 or so years ago. No matter what line you follow, however, using biblical evidence alone, all that we can show is that the earth is no younger than several thousands of years. The young earth creationists would argue it also shows the earth is no older than several thousands of years, and importantly, it's 5 days older than Adam. Inherent in the tenets of young earth creationism is not only the rejection of evolution, which I'm not really going to talk about tonight, that's another matter altogether, but also the rejection of the principles of physics and chemistry. We hear a lot about the teaching of creation in our schools, creation versus evolution. Do you know what your school teaches? But few people realize the corollary, that if we reject evolution to account for a young earth, we reject the principle of uniformitarianism, the present is the key to the past, which is a foundation for the science of geology. And in so doing, we must allow that physical processes didn't work the same way during the week of creation as they do today. Traditionally, the opposite camp in the age of the earth debate is that of the scientist, quotes. Here, the stereotype is of the person who understands that physical and chemical processes, as we know them today, were responsible for the formation of the earth and the universe, and that God, if he does exist, is no more than a bystander or a spectator. Dawkins refers to him as the blind watchmaker. Most people in this camp are agnostic. Some are atheistic. For most of them, Christianity may have been of little interest or concern. My experience in dealing with scientists is that the majority fall into this camp. I emphasize that most scientists I have encountered are agnostic. Only a few have questioned the Christian gospel and deliberately turned away from it. Most simply have little concern for things spiritual. In this way, I believe that most scientists are really no different from most other people of the 1990s who have chosen not to think, but they haven't even done that, who simply have not thought about the Christian gospel. I think you can agree that science and an all-encompassing faith in it is such a pervasive force in our society that the majority of people, not only scientists, can be termed agnostics without them even knowing why they are so. Our society, at least in the developed world of the West and the North, has become so accustomed to expecting that science will solve its problems. Science will find cures for its maladies. Science will attend to its entertainment. And science will approve its lifestyle, that many people have tacitly placed their faith in that science. Now, as no one today can really be knowledgeable in all the diverse fields of late 20th century science, I believe that means that all of us, eminent scientists included, have to take most aspects of science as a matter of faith rather than understanding. I know a bit about geology, precious little, I wish I knew more about chemistry, and virtually nothing about sciences involving psychology. One wonders if perhaps the faith of the agnostic scientist in his or her science has resulted in an avoidance of the consideration of a faith in God. I wonder if it's so much more self-reassuring to have faith in our own works rather than an external being. As an aside, it's kind of interesting to observe how many prominent scientists in the 18th and 19th centuries were also well versed in theology. Ironically, in the earth sciences in particular, there are many prominent names from the early days that were almost as well known for their writings on the Bible as for their writings on geology. And what's more, they probably didn't realize they were writing about different things. The subjects were not radically different in their minds, for the investigation of the natural world to so many of these men was merely an extension of their investigation of Scripture. It's only in the second half of the 20th century, I believe, that many scientists have drifted away from a faith in a creator God who has set the whole creation in motion and for a purpose. Well, I've presented two opposing end members in the debate. At first glance, it might seem impossible to be both a scientist and a Christian today, or at least a scientist and a Christian who believes in the reliability of Scripture and the age of the earth, the great age of the earth. Surely the earth is either 4.6 billion years old and the Bible is wrong, or 6 or 10,000 years old and science is wrong. However, thousands of scientists are alive today who are professing Christians. And just as there are thousands of scientists, there are thousands of shades of interpretation between, and in some cases, unfortunately, beyond, the two opposing viewpoints that I have described. In fact, in California, where else, there's a research institute, the Institute of Creation Research, which is dedicated to proving the young age of the earth. It includes on its staff Christians with geological training, some with PhDs in geology. They do not, of course, deny that the earth looks very old, because it does. And they claim that if using physical and chemical processes at current rates of these processes, then the earth does appear to be billions of years old. But they argue that the apparent antiquity of the earth is a result of changes in the rates of physical processes, either after the flood or at the end of the creation week, or alternatively, that the earth was created with an appearance of old age. Let me just describe these grounds, because you may or may not have heard of them, and if you have heard of them, you may wonder where this person is coming from. The first line of reasoning, that physical processes have changed their rates, is a very difficult one to argue. It's like trying to discuss science without being allowed to use the laws of science. It's like trying to bake a cake without being allowed to use flour or heat. They would claim that the annual or the seasonal deposits that we see in our seas, for example, or in the rocks, for example, occurred not annually, but in a few seconds. That radioactive decay processes, the geological clocks that I referred to earlier, have not operated at the same rate throughout time, but have slowed down by millions of times, and that generally it's the flood that's blamed for it. This was responsible both for the change in rates of physical processes and for the deposition of all those sedimentary rocks. Such reasoning would lead us to the assumption that things before the flood must have been very, very hectic indeed. But Methuselah and his contemporaries lived very long lives and got through it. This version of young earth creationism is sometimes referred to as flood geology, by which nearly all the geologic strata were laid down in the one-year flood of Noah's time, rather than over a period of billions of years, as most geologists would claim. Let me deal with this hypothesis of flood geology first, because I believe it represents a major misinterpretation of the geological record. If the Earth really is young, then there is the enormous problem of explaining why the Earth is covered with miles and miles of rock, which give every appearance of having been hardened from once soft sediment. Where did all that sediment come from? Did God create it in the first place, with all its fossils in it, just to mislead those who would not believe his word? Most Christians who have familiarity with geology are, to say the least, uneasy with the idea that animal bones and fossil clamshells and petrified wood never really were living things, or that dinosaur tracks were actually never formed by a dinosaur foot. Flood geology is an attempt to explain all these phenomena more naturally within a young Earth perspective. All these fossils really were living things, according to flood geologists, but they died and were deposited in the sediments that caused by Noah's flood. Flood geology can look impressive to those untrained in geology, and although it does, there is still a large amount of embarrassing data that are available to show that it will not do what it promises. It does not provide a natural explanation for the Earth's rock layers. How can you account for desert sandstones in a global flood? Desert sandstones are deposited in a dry land. Or locally, the thick layers of gypsum that you see on Highway 101 on the way to Halifax, which were formed by the evaporation of seawater, not by an all-encompassing flood. The presence of fine layering in some strata is another problem. There are many places in the world where there are thousands or even millions of layers consisting of pairs of different rock types, often only millimeters thick, for example, alternating layers of clay and sand. These are usually explained in geology as resulting from annual deposits in lakes or under the sea in response to different rates of precipitation, and therefore different rates of river runoff and different amounts of sediment in these rivers in summer and winter. In flood geology, we have only 1 year to accumulate all these layers, although I have read an argument that postulates carefully coordinated waves were responsible for doing it, bringing fine silt from one direction and sand from another direction, alternating each other, producing the clay-sand alternation. That this happened with such perfect regularity, with every wave over areas of thousands of square kilometers in extent in many parts of the world, I find difficult to accept. The other line of reasoning proposed by people, members of the Institute of Creation Research, is the old Earth creation alternative. This hypothesis postulates that the Earth was created relatively recently, in the past 10,000 years or so, but with an appearance, an artificial appearance of great age. Proponents claim that a major advantage of an old Earth creation is that it takes both the text of the Bible and the text of nature seriously, inerrant and straightforward. This is important for theologians because they read in Psalm 19 that the heavens declare the glory of God, and that is interpreted to mean that the natural environment is just as valid as Scripture in interpreting the formation of the earth. It's not possible, by the very nature of the reasoning, to really argue against this line. If God created the earth old, then presumably he did a perfect job of it. All geological investigation will lead to an age that he originally set within it, presumably the 4.6 billion years that we have measured. My main concern with this line of reasoning is that it sounds like someone is pulling a huge April Fool's joke on us. And I find it difficult to put my faith in a God who pulls such tricks. But even if it were so, if he wants us, for some unknown reason, to believe that the earth is old, and it isn't, I would rather follow along with his plan than question his reasoning. Some of these groups of scientists are often considered the crackpot fringe. The overwhelming evidence negates their point of view, but still they stick to them. Unfortunately, they have been very, very vocal and have probably, more than anything else, served to alienate many scientists from even considering Christianity. Their theories and their hypotheses are so obviously flawed to the scientific mind that the scientist simply dismisses them as worthless. Equally unfortunately, they have been very active in some Christian denominations, stirring up notions of scientists as conspirators in an anti-Christian campaign, and have caused many Christians to regard science as an evil influence, with an underlying goal to disprove or abolish Christianity. It's quite a contrast, if you think about it, from the early days of scientific investigation, when the church and the scientists worked together to demonstrate the magnificence of creation. Other groups have in their mind the best interests of various communities. The extent of human reasoning to explain the apparent contradiction between the biblical record and the natural record is truly phenomenal. There are those who would claim that the days referred to in Genesis 1 are literal days, but that millions of years passed in between them. Others, using the line in the Psalms that a day is like 1,000 years to the Lord, claim that the days are not 6 24-hour sequential periods, but simply periods of time of indeterminate length. Personally, I find myself lying closer to this idea. Yet others consider the entire first 3 chapters of Genesis as a parable, that there was no literal Adam and Eve, and that the events described around the creation were simply an inspired prologue to the dealings of God with his people. One must wonder about the extent of the details described, however, not only are specific events and places mentioned, but many names are introduced for no other reason, it seems, but to continue the line of descent from Adam down through to Christ. Yet another line of reasoning involves time warps. Adam appeared on day 6, okay. God alone was watching the clock before that, and his frame of reference, which might be close to the speed of light, in that frame of reference, 6 24-hour days are equivalent to 15 to 20 billion years from the human frame of reference. I can provide equations for that for anyone who wants them later. As you can see, a great amount of effort has been placed into figuring out just how Genesis chapters 1 to 3 relate to what geologists have uncovered in their investigations into the development of the earth. In fact, I'd hazard to guess that other than for the Great Commission in Matthew, more people have been inspired to work as a result of and for an understanding of these chapters than any other part of Scripture. I'd also guess that in our so-called enlightened age, when we seem to be able to turn science to do almost anything for us, more people have rejected Christianity because of these 3 chapters, or more accurately, because of the belaboring of all sorts of wild and woolly hypotheses to explain these 3 chapters by those who feel the need to explain them. Early on in my journey of faith, I was confronted by a soil science professor who asked me how I integrated my study of geology with my Christian faith. That question again. This man was different, however, because he came from a Christian perspective also. His advice to me still stands me in good stead. He reminded me the Bible was written by people without scientific training, for people without scientific training, to explain why they were God's chosen people. He told me that the Bible is not a textbook in science, and nowhere does it purport to be so. The fact that Genesis 1 got the events of creation in the right order, at least from an earthly point of view, merely goes to show that the author, God, knew what he did. So maybe you're asking yourself, what is the answer? Is the earth old or is it not? Well, as a Christian who is also a geologist, let me tell you that I have never really had any problem understanding the text of Genesis in the light of my scientific education and investigations. I routinely work with rocks that are 500 million years old. I teach a course that deals in part with the early history of the earth back to 4 billion years ago. And I discuss the history of the moon, where geological activity began and ended before 3.8 billion years ago. I have little difficulty accepting my own observations of the great antiquity of the earth. I also teach a course, or at least I did until a year or so ago, that investigates the processes that occur at great depths beneath our feet, 15 kilometers or more underground. And to be honest, I find it easier to think of things happening billions of years ago than things happening right now, 20 kilometers below us. I also believe that my faith is increased by my understanding of science. The more I learn about the incredible complexity of our planet and the universe, the more awe I have for the God who planned it, created it, and set it in motion. And the more convinced I become that there is a divine reason that masterminded it and a divine plan that sustains it. In this light, you may have heard recently of discussions about the date of the Big Bang. Not everyone believes in the Big Bang, even in the scientific community, but the majority of physicists, I believe, do. It's been observed for a long time that the galaxies in the universe are hurtling apart from each other at phenomenal rates, somewhat analogous to the pieces of shrapnel from an exploding mine all flying out in different directions at great rates. As they fly out, they fly apart from each other, and the galaxies in the universe are doing the same thing. Light traveling from the stars in these galaxies moves at a rate of about 300,000 kilometers per second, and nothing today travels faster than that. Today we can observe light from the very most distant of these objects. It's taken about 12 billion years for that light to reach us. The actual value is what's been hotly debated over the past year, and the estimate has ranged from as low as 9 billion years to as much as 15 billion years. However, the important thing is that we appear to be glimpsing events that happened about 12 billion years ago, give or take a couple of billion years. The Earth and the whole solar system, by comparison, is only a third of that age, so it's well back beyond the formation of the solar system. We're slowly getting to a situation where we think we can speculate on what happened when the universe started. I want to take you back in time then by looking at first at some of those distant stars. back to the time when the universe got going. Using modern physics, the analysis of processes known to happen today, we can calculate what conditions were like back almost to the start. 1 billion years after the Big Bang, quasars had formed. Those are the oldest of stars, and those are the ones that are being glimpsed back out at 12 billion light years away. Normal stars were just in the making as stellar gas clouds, but they were coming along nicely. At this time, the temperature of the universe, which started off as extremely hot, had cooled down to about 15 degrees above absolute zero. That was 1 billion years after the Big Bang. 10,000 years after the Big Bang, the universe had cooled to an average temperature of 3,000 degrees. However, we can calculate much further back than that, although I warn you, some of the numbers get rather difficult to imagine. 3 minutes after the Big Bang, the nuclei of atoms had formed, but it was still too hot for electrons to be maintained around these nuclei. The average temperature of matter was about 1 billion degrees. About 1/1,000,000th of a second after the Big Bang, the nuclei of atoms had formed, but it was still too hot for no, I beg your pardon, wrong one. The universe was the diameter of the solar system. 1/1,000,000th of a second after the Big Bang. Protons and neutrons had formed, but they weren't together in nuclei yet. It was too hot for them to combine, 10 trillion degrees. In fact, right back to 1 trillionth of a second after the Big Bang, the universe was a smooth mass of matter, although some of the ripples in the distribution of matter had been initiated. These are the ripples in the universe that got quite a bit of press time when they were discovered in 1992 by the Cosmic Background Explorer satellite. The satellite detected subtle variations in the temperature of the background microwave radiation. Those temperature fluctuations, that background radiation permeates the whole universe, and the temperature fluctuations are thought to have arisen from differences in the density of the cosmic matter and energy, and have been described as wrinkles in the fabric of space. The wrinkles had actually been theorized about 20 years earlier, but they were discovered in 1992. There were many scientists waxing eloquent at that time, descriptions like "We're viewing the birth of the universe" by Joseph Silk, who was a long-time Big Bang proponent, or "If you're religious, it's like looking at God" by George Smoot, who was the leader of the research team. We can go even closer. Before that minute fraction of a second after the Big Bang, matter could only exist as energy. But back to 1 billion trillion trillion trillionth of a second, or for those of you familiar with scientific notation, 1/10 to the 45 of a second, after the Big Bang, it's still possible to postulate or calculate conditions. At this point, gravity has just broken free from a single unified force, and our universe is composed of energy and expanded to the size of an atom. It's inconceivably hot, but cooling as it expands. Beyond that, well, physics stops about there. The scientist is left wondering what it was before then. I believe that the Christian can read it in Genesis. In the beginning, God. Any one of us might wonder what it was like before the beginning. However, to do so, we must consider the time before creation. But the concept of time, does it have meaning before creation, before the beginning of the universe? When St. Augustine was asked what God did before he created, he replied that time was a property of the universe that God created, and that time did not exist before the beginning of the universe. I like this concept, and I think it's a very insightful idea, and it gets us back to the notion of time as a commodity. As I've described, I deal with time, with great swatches of time, as I unravel the geological development of Nova Scotia. And what happens in a clock? Do we all have watches now, and we watch them over? We've been trained to be very precise about time, in New Testament time. And we're all very aware of time as we watch the hands in a clock move. Or do we all have LCD watches now, perhaps, and we watch the seconds turn over? We've been trained to be very precise about time. In New Testament times, it was generally good enough to say about the 3rd hour or the 9th hour or whatever the hour was. Minutes didn't seem to have that much significance. When I grew up, it was good enough to say 5 to the hour or 10 past the hour. I can remember the first time I heard the 5-minute barrier being split by a Radio 1 DJ. He claimed it was 8:37 or 23 minutes to 9. That wasn't a sign of increased precision in our clocks, I don't think. It was a sign of increased speed of living. It's now 8:31. No one raises an eyebrow at such precision. Our computers calculate time to 1/100th of a second or better. Fortunately, they keep that hidden from us. Time, as you see, is a commodity of escalating value. A minute today is worth what an hour used to be. We photocopy a page in seconds, where a secretary may have taken an hour to retype it. Even in geology, time is appreciating. 20 years ago, we could date a rock to within about 50 million years. Last year, I read a paper that compared the ages of ancient volcanic rocks in northern Ontario. Their source volcanoes were 2753.2, 2753.8, and 2754.1 millions of years old, give or take 240,000 years. And sure enough, lava and ash from the youngest one cover the lava and ash from the two older ones. We seem to busy ourselves consuming time at ever-increasing rates. Where does all this lead us? Will we continue to live faster and faster lives? Will it make our lives feel longer or shorter? Will it give us more time to relax or to slow down? Or will our relaxation just become more hurried as well? Think of what your grandfather would have said about how you live today. So what are we to understand then about how God deals with time? In all the recent flurry of activity concerning the origins of the universe and the integration of all science into some single unified theory, I can recommend one book to help you understand the non-Christian point of view. The English physicist Stephen Hawking has written a brief history of time. Now, I'll warn you, the book is not a bedtime story, even for most scientists. It's written for the lay reader, yes, but you'll find it challenging intellectually as well as spiritually. But Hawking closes with this statement: if we do discover a complete theory, it should be understandable by everyone, not just a few scientists. Then we shall all, philosophers, scientists, and just ordinary people, be able to take part in the discussion of the question of why it is that we and the universe exist. If we find that, it would be the ultimate triumph of human reason, for then we would know the mind of God. Let me emphasize 2 lines from that quote. Then we shall all be able to take part in the discussion of the question of why it is that we and the universe exist. The Westminster Catechism asks, what is the chief aim of man? Why do we exist? The answer is the chief aim of man is to glorify God and enjoy Him forever. Faith in God or faith in science? I believe we can have both. Just remember who made the science in the first place. And as for time, let it be yet another aspect of creation. Praise God that when we are called home, we will pass out of the shackles of time and be able to glorify God and enjoy Him forever, truly. Thank you.